Hey everyone, let's just wrap up our lesson on the second derivative test. Just a quick summary. Number one is we always have to find our slope equals zero or where the slope is undefined. If we're talking maximums and minimums, though, we want to know where the slope is zero at because that's the top or bottom of the curve. Without using the first derivative table, we can always work with the second derivative. And our nice little diagrams here are basically showing that whenever you're concave up, it doesn't matter what x value you put in here, you will get a positive number. So if you're at any one of these 5 points and you go f prime prime of that x value, you get a positive number. And over here, when your function's concave down, it doesn't matter what x value you put in. When you do the second derivative of that x value, you will get a negative number. So how do you know if you have maximums and minimums? It's two thoughts. Where is your slope zero? That has to happen first. You need to know where your slope is zero. Once you have that x value, you figure out what kind of concavity you have. All right, so let's just again kind of walk through a couple of examples showing us that information. Step one, I found where my slope is zero at. Step two, I found my second derivative. Now this one's a little bit different. If you look at the function x squared plus 2x minus 3 takes you back to math 20, you recognize that's a parabola that opens up. This second derivative is telling you, yes, it is a opening up parabola. It never goes down. It never has a zero. There's no points of inflection. So your two thoughts, -1 is a zero slope, and it is concave up. So -1 is a zero slope and concave up, so -1's a minimum. And what is the -1 value? You go back again to the function. Don't put it in f prime. That'll tell you it's zero. Don't put it in f prime prime. That's going to tell you it's positive. You want to know where the point is. So the point with -1 is -4. -1, -4 is your vertex, or it's your minimum value, right? And if you graph it on some kind of application, you can see that point. We can any function, and we're doing polynomial functions. Later on in the unit, we'll do things that are rational functions. Where's my slope equals zero? At -2 and 2, my slope equals zero. So I got critical numbers for my first derivative. I'm finding critical numbers for my second derivative. Again, a critical number in my second derivative tells me I'm changing from concave up to concave down. So a point of inflection is 0 and -1. Now, what kind of concavity do I have with my zero slopes? When x is -2, I get a negative second derivative. So I am concave down with a zero slope. That's the maximum at -2. When I put in my x equals 2 value into my second derivative, I get 8. So that means I am concave up. When x equals 2, I'm concave up and a zero slope. I must be at the bottom of the curve at f of 2. So again, how do you find your values? You go back to your function. F of x equals x cubed minus 12x plus 1. Plug in -2. Your maximum 17. F of x equals, plug in 2 cubed, 12 times 2 plus 1 is -15. Now you've got your local maximum and your local minimums. And again, region of concave down, region of concave up. The boundary in the middle is your point of inflection. Lots of algebra. And the last example we're going to look at is about 1/3 x cubed, etc. Find a derivative. Gives me two 0 points. 3 and -2 are my zeros. My second derivative is 2x minus 1. So I get a point of inflection when x is a half. So I got two places where I have zero slopes, and I have one place where I have a point of inflection. And I didn't finish the algebra there, but we could easily finish that off. And ideally, you'd finish it off using fractions. So what we're saying with our derivative test is my slope is 0 at -2. What kind of concavity do I have at -2? And I plug it in 2x minus 1 for my derivative, second derivative, -5. So when my x is -2, I am concave down. When my x is +3, 2 times 3 minus 1 is 5, I am concave up. So then my two thoughts are at -2, I have a zero slope and I'm concave down. So at -2, I'm zero slope and I'm concave down. That has to be maximum. So again, I go back to my function and I plug in -2. I can figure out the maximum value. F of 3 is going to be a minimum. And the reason it's a minimum, we know it's a zero slope and we know it's concave up. Again, plug in the 3, work it out, and you can use those values then to help you draw some graphs. At -2, it's the top of the curve going from increasing to decreasing, or it's a region of concave down, right? So first derivative test would still work here. You could do increasing table, decreasing table. Between increasing and decreasing is a maximum. Here you've got a region of concave up. At the bottom of the concave up curve, you have a slope of 0. So when x equals 3, the slope is 0. It's concave up, it's a minimum. Between concave down and concave up, you got this nice little point of inflection. And so the tangent curves are all above, tangent curves are all below. All right, there's your second derivative test. Looks like you're ready to try the homework. We'll go from there.